Hello guys, welcome back to this works. Let's solve today's POTD. And one more thing I want to clear that if you just want to see the solution, then go back. This video is not for you because I'm not here to just to provide the solution. I'm here to explain. So now let's come to the problem. So given an unsorted array, important thing is unsorted, okay, of integers, and we are given a target sum like the sum we want to make. Determine the number of subarrays whose element sum up to the target value means like determine the number of subarrays that have sum equal to target. Okay, target is given. So you can using like you can solve this problem in various method, but time complexity will be different. So suppose if n is up to 10 to the power 3 something, or like if you can solve this in order n square, then what you will do? You are given an array, okay? You will make the prefix sum. I'm assuming here, like you know how to calculate the prefix sum. Prefix sum is nothing but like what is p sum of I? P sum of I is the summation of ARR of J, I can say, where J belongs to J is 0 to I. Okay, this is the prefix sum means simply. You can calculate this in order n, and let me add the like pseudo code for this, like for int I equal to 1 to I less than n I plus plus prefix sum of I is equal to nothing but prefix sum of I minus 1 plus ARR of I. And one thing like prefix sum of 0 will be 0. So not 0, ARR of 0. So this is the simple things. Like here if you see, like suppose you have a 10, 2, 3. Prefix sum of 10 will be prefix sum of 10 will be 10. Now prefix sum till here will be 10 plus this 2, 12. Now this will be 12 plus 3, 15. This is the prefix sum, you can see 0 to 0, 10, 0 to 1, 12. This is 15. Okay, this way you can calculate the prefix sum array. Okay, prefix sum array what tells? Prefix sum of I tells the sum of indexes 0 to I. Okay, so this is the prefix sum things I have explained. Now you have calculated the prefix sum, and we want the target. So what is the sum? Suppose this is the array, okay, 0 1 2 3 4 5 6 7 8. These are the indexes. So if we want the sum of here to here, like sum of here to here, okay, so what I can do, like I have prefix sum and I want to find in the order 1. I want to find in the order 1 sum of in sum of elements from index 3 to 6. So what I can do, can I do this thing? Prefix sum of 6. Prefix sum of 6 will be from this index 0 to here, index 6, minus prefix sum, we are including 3, that's why minus prefix sum of 2, then minus remove this part. So if in this in this complete part I remove this part, and what will remain? This part will only remain. Okay, so you can say this way. So this way, if you want to find a sum from index L to R, in these are the indexes, summation of L to R will be nothing but P sum of R minus P sum of L minus 1, because we want to include the L, so that's why we are removing, like subtracting from L minus 1. So here you can see we want till this, we want to include this 3, so we are removing from this 2, this we are removing. Okay, so this is the one thing that I want, like some L to R this way. Some L to R is nothing but prefix sum of R minus prefix sum of L. So this way you can calculate for any range. So now what you will do, you will select for, like, now you will, what you will do, you will select any 2 points in the array and you will check whether sum is equal to target or not. So this way you can solve this question in order n squares, like for int I equal to 0 to n, int j equal to what it will, here what will come, 0 doesn't make sense, because if suppose I is here, then j cannot be here, j should be ahead of I, then I to j will be a subarray, so j should start from I, so j less than n, j plus plus. Now current sum is like summation of I to j is, in current sum I can say current sum will be this here. Okay, so oh, sorry, L minus 1, here will be L minus 1, sorry. So this will be here. So now one more thing is, like suppose this L is 0, if L is 0, then this will become minus 1, doesn't make sense. So if L is 0, so what it means, we want to sum from 0 to R. If L is 0, we want to sum from 0 to R, so this will nothing but P sum of R. So if L is 0, we will not keep this thing, okay, this will only do this, okay. So how will you write this in code? Because if you keep L equal to 0 in this formula, this will become L 0 minus 1 minus 1. So you can directly write the here, like here you define int current sum, P sum of R is here j, and if I is greater than 0, then current sum minus this part, what, I minus 1, because here over L R is nothing but I and j. So this way you have find the sum. So now if current sum is I, current sum, if current sum is equal to target, then count plus plus answer plus plus and this return this count, okay. So this way you can solve this question in order n square, okay. So sometimes this approach is fine, okay. So now but you have to solve this question in order n, suppose yeah, actually we have to solve this in order because it was expected time complexity, and suppose n is up to 10 to the power, n is around 10 to the power 5, then you cannot solve this in order n square, okay, then you have to move to the second approach, okay. So now, okay, we want to calculate the subarray. Suppose this is the array, so any subarray will have the sum equal to target when p sum of, if subarray r minus p sum of l minus 1, this is the sum of l to r equal to target that we want, okay. So we are iterating over r, suppose we are iterating over r, suppose we are iterating over r means r is moving from j to 0 to n. So now this, if r is for a particular r, this is fixed, this is also fixed, so this will move, no? So suppose r is for r, for particular fixed r, what will become, p sum of l minus 1 is nothing but this will go this side, this side, it will nothing, it is nothing but this or not, for a fixed r, suppose like we are iterating over L to for fixed. If we were suppose we are at any time we are getting for r equal to 2, r equal to 3, 5, 10, anything. So this will fix, this will fix to what we want. Okay, so now what is happen? Suppose we are at this, r is here, r is fixed. Okay, suppose we are fixed for any particular r. If we want to L to r sum equal to target, then our prefix sum of L should be this. This is, are you getting this or not? Because L to R sum is this, and we want to make this equal to target. And if we are fixed any R, like suppose R is here now fixed, then P sum of L minus 1 should be P sum of R minus target or not. Okay. So now for a fixed R, we will check how many L are there such that their prefix sum is equal to this. Okay. And how we will check? Whenever we will move forward, we will put that everything in the map, or we will count the frequency. Okay, so let me run this on an example. Okay, so here is the subarray. 10 to minus 2 minus 20 and 0. Target is minus 10. So suppose as I said, we will loop over r. R will move from 0 to n. N is the size of subarray. So that's it. Then what is our required, like PL minus 1, prefix sum of L minus 1, prefix sum of L minus 1. From here you can see prefix sum of L minus 1. Okay, I can't. It's nothing but like from here you can see prefix sum of L minus 1 is nothing but if you do this side, this will come this side. So P sum of R minus target. Okay, so this will be prefix sum of R target. Okay, यहाँ तक कोई दिक्कत? Prefix sum, I have already told you this way you can solve the prefix sum, like this is the code to calculate the prefix sum. Okay, so this way. So now what we will check, how many times we have got this prefix sum. This is nothing but prefix sum of L minus 1 na, from the equation. So how many times we have got this? So when you add this, so this is prefix sum of till here is 0 is 10, target is minus 10, this becomes 20. So how many times we have got 20 till now? We have not got any time, so we have not got, so count plus equal to 0, like एक भी बार नहीं मिला तो count में इंक्रीज नहीं हो सकता now. But we have got this sum 10 we have got now, we have till here we have got this sum 10. So frequency of 10 will become 1 here. Okay, so now when we will come this till this, like r equal to 1, this will be 10 plus 2 12, and target is minus 10. This is became 22, right? 22. So how many times we have got 22? Because required ultimately we want this 22, we got 22, no, so nothing. But now we have got 12, because next time when we will reach here 12 will be available, some 12 will be available, so we have done this. Sorry, this video is getting bigger, but I want to explain it completely because this is a really nice problem and important for coding questions. So now this is become minus 2. The prefix sum of till to prefix sum we are at here are equal to 2, 0, 1, 2. Prefix sum is 10. 10 plus 2 12, 12 minus 2 10. and target is so 20. 20 is not available, still 20 is not available, so no increment in count. Okay, but now 10 is available twice. Can you see? Because again sum is 10, 10 plus 12 plus minus 10, so this 10, 110 is this and 110 is this. Okay, sum is, here is some 10 and here is some 10, so this is 110 and some 10 is available twice. Okay, and one more thing, like some 0 is always available. Okay, some 0 is always available because if our L is this, L is 0, then some 0, L is 0, then some 0 is always, you can think like some 0 is always available. You can think of these things like, okay, because when like this will come, suppose this 5 and 5 or question and target is 10, when you will reach here 5 will be available. Okay, and we want this target, so 5 minus, suppose target is 10, 5 minus 10, okay, some prefix sum 10. Okay, suppose this is a small question, 5 5 and target is 10, target is 10. So when we will reach here, what we will do, we will do prefix sum of r, prefix sum of r is nothing but 5 plus 5 10, minus target is 10, so we want 0. If you see, if you don't increase, like if you don't make this, then you will not get any solution, but there is a solution. 5 plus 5 10 is the solution of target, like 5 plus 5 is equal to target. So this way, because 0 0 is available, means we are starting, this is our L, like we are starting point, first point. Like if our L is this, suppose our L is this, then prefix sum of L minus 1 what will be, this will be nothing but 0. So this is always available for us. So this way, that's why I'm saying some 0 is always available. Okay, so हमने कहाँ तक कर लिया? Okay, now we are at here. So prefix sum is 10, 10 minus 10 minus 20 minus 10. Prefix sum here is minus 10. Okay, if you see, calculate prefix sum till here is minus 10 minus, so ये क्या हो गया, 0 हो गया. This is 0, prefix sum is 0. So what is required, so like this is required is nothing but p sum of L minus 1. Okay, so we want 0, 0 हमारे पास available है one time, so we can increase the answer by 1 because 0 तो available है. Okay, so now what we will do, now this we are getting here prefix sum 0, so now for next 0 will be available twice. Okay, so now we are at here, then for at here 10, what is the prefix sum, we are at here, what is the prefix sum, prefix sum is nothing but 10, to cut cancel out 0, again here to your sum, prefix sum is 0, so this is 0 minus target is minus 10, this is become 10, so we want 10, required is 10, 10 is available twice, so answer plus 2, so our answer is 3. This is our answer. So how this is happening, like what I'm saying, like for this 10, for okay, for r equal to this, we want the sum, this is prefix sum of L minus 1 should be 10, so prefix sum of L minus 1 should be 10 means, if you see here, if L is 1, if L is 1 and R is 0 1 2 3 4, R is 4, then you will see prefix sum of L minus 1, prefix sum of L minus 1 is 10, prefix sum of L minus 1 is 10, prefix sum of 0 is 10, and prefix sum of R is nothing but 0. Then you can see 0 minus 10 is minus 10. Okay, this way it is happening. So you can solve this way. For keeping the frequency count, you can use map, but map will give you the order n log n. So if it is good to use an ordered map, that will solve in average time complexity of order n's only. So that's why I use an ordered maps. Okay, so I hope I have cleared everything. So now let's see the little bit of code also. So that things this is the unordered map. I as I said 0 is always available. So 0 is I made the 0 available, like some 0 is available. Now this is the current, this is the sum. Okay. So I why I have not made prefix sum, because we are making the availability this way, like after completing this iteration for this next one, this will be available. So okay, this way. So this way after the iteration I am making it available. So initially nothing will be available instead of 0. So I am making it available like this. So this is the prefix sum. Prefix sum will look like this. Okay, this is the sum of p of r. This I is r. So this will look like this, and the requirement is the sum minus target. Okay, because sum is the prefix sum. Okay, this is nothing but p sum of r. Okay, and r is I. I have noted r with I. Okay, so this is the required sum, and this is the required, this is nothing but you can say p sum of l minus 1. So now we calculate the frequency, how many times it is available, we add it to the answer, and we make the, for next iteration this p sum will be available, for next one this p sum will be available. So we increase the frequency count, and this way we return this answer. If you talk about time complexity, is it the order n, and space complexity is also order n, because we are using unordered map and we are pushing everything. So it is also order n, and time complexity also order n. So you can now have explained both methods, order n square and order n. So I hope I have cleared everything. Thank you, and please subscribe the channel if you find the video useful, and like the video. If you have any doubt still, you can ask me in comment section. Thank you.